The topic we're going to cover today is operating systems security.
See,
Yes.
I can see the screen now.
Can you see it now?
Yes, sir.
Okay, perfect. So the topic we're going to cover for today is operating systems security, which is study unit 9 in the study guide. We will cover the following learning outcomes: describe security issues that relate to operating systems, explain various design issues for file system security, list the types of intruder behavior patterns, itemize and explain the various types of intrusion techniques used to breach computer security, list and differentiate methods of access control. Okay, so when we talk about operating system security, we're more concerned about a single computer. Most likely, this single computer has a processor which is multi-core. Okay, we're not really looking at it from the perspective of a server. Okay, because a server already has its. Yes. Someone's mic is unmuted. Please, if you're joining us now, make sure that you mute your mic. Okay, so what we are saying is that we are discussing operating system security from the perspective of a single machine, not from the perspective of a network. But we can agree that if you initiate security properly at the host level, that's why you refer to it as the host level, then ultimately the network protection actually increases. So we say one OS is in control. Threats come from multiple users or from external access. Okay, so even you from your computer sitting in front of you now, the threats can come from multiple users. I mean, you can leave your device unattended if you don't have a password or a PIN. Somebody can come in and do things. Okay, so multiple users, or it could be that anyways this computer is being accessed by multiple people at the same time. Maybe it's one computer for your home, but you still need to secure it because each of the users for that computer have their own confidential files. Or it can also come from external access. So threats can come in from externally, outside the network, or you as the user are doing remote access to a computer at work. Maybe you're working from home, so you're doing remote access to a computer at work. Now, for the fact that you can do remote access on that computer means that immediately it's vulnerable because other people who are intruders can exploit that remote access feature. Okay, so then we say that we can categorize our threats into two main categories: intruders, okay, or actions done by people, humans, and then we have malicious software. Okay, so it's threats in the form of software. Intruders, modern systems usually allow remote access from terminals, from the network. Intruders can use all of these to break in. So an intruder is someone who's constantly looking at for a vulnerability to exploit. This may be a technical person or maybe just a regular curious employee in the organization. Okay, so you don't really have to write code or be sophisticated to be classified as an intruder. How do intruders get in? Usually by masquerading as a legit user, less frequency by inserting commands through insecure entry point. So you find that most of the time, an intruder is someone who's already in the organization and they are maybe they have credentials of someone else or something like that. So they are masquerading as a legit user. They masquerading as that person. Okay, they're impersonating that person to gain access to the system. It's very rare that you'll find an intruder as someone sitting behind a computer typing away commands. It does happen, but it's rare. And so we say that most frequently it's someone who's masquerading. Holds in electronic mail. Okay, so intruders also can send people emails or spam, and then people click on those emails, and then it infects their computer with some sort of malware. So the intruders themselves can get in through malware. Okay, making use of interpreters that access data remotely. Okay, so they can make use of sniffers and interpreters, which could be sniffing network traffic. How do you go about detecting intruders? The sooner detected, the better. Systems that detect and eject intruders quickly are less attractive targets. Okay, information gained from detecting intruders can be used to prevent further intrusions. Detection presumes you can differentiate the behavior of authorized users and intruders. So there are certain systems we can put in place in the organization to detect intruders and reject them from accessing the network. And we're going to talk about that later on, but just know that it's a system-based thing that we can implement to detect whenever a policy has been violated. If we say a user cannot delete this file on a desktop, and then the user knows very well that they don't have a right to delete any files on the particular computer that they are on, but then again they try and they right click on the file and they click on delete. Of course, the system is going to give an error to say you don't have permissions to do so, but there should be an intrusion detection, some sort of detection system that picks up when a rule has been violated, so that it notifies someone who's an administrator. In terms of financial systems, we call these audit records or audit trails. So whenever a transaction is performed on the system, okay, it involves some sort of monetary financial linked system. There's going to be an audit that is done, an audit trail, okay, audit recording. So every transaction is recorded so that if somebody steals money or whatever, we have a record of that, and it can be used to further prosecute the person. So the types of intruders that we have masqueraders, refers to a person who does not have the privilege to access a computer system. Masqueraders penetrate a system to exploit someone's account who has got the rights to use the system. So maybe one user, let's say someone was working as an administrator in a company previously, and then they leave the company. And the company makes a blunder by not changing the administrator password. So now the new administrator comes in with the same password as the predecessor. What happens? What happens is that now we can have someone who can masquerade, because now two people have that password, okay? And it can exploit the current system administrator's account. So that's how masquerading happens. You have access to someone's credentials and you're logging in as if you're that person. Obviously, the computer cannot tell that you are truly that person unless there are some sort of biometric systems being put in place, which is it's an additional layer to proving that you are who you are. So, and then we have a misfeasor, refers to a legitimate user can have access to items that he or she is not supposed to have access to. Okay, so this person is, they're just looking around for something on the system, and it happens that maybe that particular data or program is there available to them, which it shouldn't be available to them, and then they use it to exploit it for their own benefit. Okay, then we have a clandestine user, an individual who seizes supervisory control of the system and uses this control to evade auditing and access controls, or to suppress audit collection. Okay, so this person, they are very slick, because they do something and then they go with escalated permissions to delete any records or any audit trails. But let me tell you something. You can never fully delete the evidence. There's always a way of tracking what a person did, okay? So malicious software regarded as the most dangerous attack to computer systems, refers to a program that takes control of a computer system to perform its own tasks. Examples of these are malicious software, viruses, spyware, and rootkits. Okay, so another name we use to refer to this malicious software, in short, to say it's malware. So if you say your computer is infected with malware, it's more of a generic description, and it means your computer can either be infected by one of these viruses, spywares, and rootkits. Types of malicious software. So we have parasitic fragments of programs that cannot exist independently of some actual application program, utility, or system program. For instance, a logic bomb. Okay, so we have a parasitic malware. Then we have independent malware, self-contained programs that can be scheduled and run by operating system, worms, and bot programs or examples. So parasitic means it needs a file at which it can attach itself to, and that's how it spreads. But independent self-contained programs can be scheduled to run and infect operating systems and computers or networks without a file. So this thing can spread by itself, and worms are example of such. Other well-known examples of programs threats is Trojan horse is one of them, and you tell yourself you're under the impression that you're downloading something that is legit, but when you actually install it on your computer, you realize that you just installed a Trojan horse. So it looks like the original file. Maybe you're looking for some sort of movie or whatever you're downloading on the internet, and you think this is it, and you download it, and then you double click on it, then that's a Trojan horse. Okay, it's not the actual file itself. It is a malware, and it comes in the form of a Trojan horse, although it looked to you as if it was the original file. Trapdoor is one of them as well. If a program which is designed to work as required, have security hole in its code, and perform illegal action without knowledge of the user, then it's called to have a trapdoor. So this is a legitimate program, but there's some sort of illegal action or code behind the scenes, and you are not aware of this. So then we call it a trapdoor. So it is the original program, but maybe it's logging your keystrokes or something like that. It's logging everything you type, and you don't have this information. You don't know. So then we have the logic bomb. As the term suggests, a bomb, it goes off after some time. So that's the same thing that applies with the logic bomb. It could work fine, and after X amount of time, then the program starts to misbehave. So logic bombs are triggered by time. Then we have a virus, okay? And this is more of a parasitic malware because it attaches itself or embeds code it embeds itself into other programs. Okay, that's what it uses to move around. So backdoors are also a problem. Why? Because backdoors are left there intentionally by developers. Okay, the reason why this happens is because they need a way to access the file system remotely. So you ask yourself, how does Facebook, for example, Facebook, you have the app on your phone, you didn't even update, but then you log in and you realize the interface has changed and they've introduced a new feature. How do they do that without you updating? Okay, it's because of these backdoors. So backdoors are left there by developers so that they can access remotely the system and make changes without the user even realizing. So we say that the biggest mistake you can make is assuming that because it's a backdoor, people won't realize that it's there, so that the level of security will not be the same as the front door, okay? But it has to be. Ensure that the front door and the back door have the same level of security. So some of the countermeasures we can use, we employed intrusion detection systems, and these could be host-based ID or network-based intrusion detection. Okay, so the use of intrusion detection systems, which can be grouped into two main categories. When you're talking about a host-based intrusion detection system, it means it's more on the end user's computer, okay, at the host level, okay. When you're talking about it from a network-based intrusion detection system, we're referring to it now that it starts at the network level. So as the traffic is coming in through the server onto the network, it detects if the traffic is malicious or not. So you can really enforce security at multiple levels. I can enforce it on my individual computer here, and then also at the network level where I'm connected at the server level, there is also some sort of countermeasures in place. We call that layering, okay, ensuring that there's different layers to protecting computer systems. So if you're looking at intrusion detection systems, they're really classified into these three main categories. You have the sensors that are constantly picking up the data, looking for data packets. We have the analyzers, receive input from one or more sensors or from other analyzers responsible for determining if any intrusion has occurred. Bear in mind that intrusion detection systems can be in the form of hardware or in the form of software. Same thing applies to firewalls, okay? So when you're looking at it from this perspective with sensors, analyzers, and user interface, we're looking at it from the perspective of a hardware-based intrusion detection system where the sensors will be there to receive input data, and the analyzers are responsible to determining if any intrusion has occurred. And then we have the user interface at which the user who wants to view if any intrusions occurred will be presented with that output through the user interface. And authentication, information that can be known by a person, a user for the system must have credentials to the system. The user must have what? A username. Okay, authentication involves you having a username, a password, a PIN, security questions that may be pre-arranged for you to prove that you are who you are if you forget or you're trying to reset your password, okay? So these are different mechanisms we use. A PIN is usually just containing only 4 digits, okay? But it's just a combination of numbers, as opposed to a password is more of an alphanumeric special character kind of combination. So an individual can possesses a security such as electronic key cards, smart cards, and physical keys. So apart from actually putting in passwords, usernames, there are also stuff like electronic key cards, smart cards, and physical keys to rooms, okay? And this could be seen as more of a physical security, okay? There's no use in putting all of these security layers on the operating system if you're not going to protect the physical environment at which they are in. An individual can use biometrics such as recognition by fingerprint, okay? So that's another layer. Or if you want to enter a room, use your fingerprint. Retina, maybe your eye scans your eye, and or maybe facial recognition, okay? All of these can are categorized as biometrics. An individual can use dynamic biometrics such as recognition by voice pattern, handwriting characteristics, and typing rhythm. So there are other ones, dynamic biometrics, where it recognizes your voice and everything like that. So access control, so this is also defined as a policy, and it refers to a security policy that is able to identify and give authorization to a device or a system. Offers security between a user and a system resource. Access control can be applied to what? Applications, okay? So if you want to limit access to applications on a network, and you set access control to say, yes, this user has the right to open this application or not. They can be applied to operating systems. They can be applied to firewalls, routers, files, databases. Very common, read, write permissions. All these different permissions that you can assign to users, okay? So firewalls, what are firewalls? A firewall could be also hardware and software based, just like the intrusion detection system. And the firewall is used to sniff traffic, monitor traffic. And you can use the firewall to set inbound and outbound rules to say, this is the traffic that can come into the network. This is the traffic that can go out of the network. Okay, so it sniffs these packets to see if there's anything dodgy, anything malicious in the naming of a file. And you can even go further in your firewall to specify that I want to block off all traffic that's coming from a specific IP address or a specific network or a specific region. Okay, so that's what firewalls do. We say they filter network traffic. Operating systems hardening. So the process of hardening your operating system is ensuring that it is very secure. Okay, so you're constantly looking for ways to make your operating system secure, and we refer to that as hardening. So the steps used to secure an operating system are, so during installation, okay, we're going to break it down slide by slide, but we do it during installation and patching, removing out unnecessary services, applications, and protocols, configuring of the users and groups permissions, configuring of resource controls, security control installation and configuration, and security testing of OS operating system. Okay, so installation of operating system. So your hardening starts, it's not something you sprinkle on top. Okay, it's not something that you sprinkle on top. From the onset, when you are installing your operating system, you must have security in mind. So something like making sure that the network that you're actually installing this operating system on is secured. Okay, so system security begins with the installation of an OS. Ideally, new systems should be constructed on protected networks. Full installation and hardening process should occur before the system is deployed to its intended location. Initial installation should install the minimum necessary for the desired system. Okay, so before you deploy this solution, before you deploy your operating system, you need to make sure that the infrastructure that it's on is well secured, including physical security, locks, and all of that stuff. Overall boot process must also be secured. The integrity and source of any additional device driver code must be carefully validated. Your hardware, what drivers is it using? Where are the drivers coming from? Who is the manufacturer? Because all of those things are exploits to the operating system. Critical that the system be kept up to date with all critical security related patches installed. Should stage and validate all patches on the test systems before deploying them onto production. So we have our production computers, our computers that we're working on, or our production server, if you're looking at it from a server level. So whenever you do things in parallel, whenever you want to install a new update or a patch, first do it on a test computer to see how it will actually react, that patch will actually react when it's in that network before you deploy it into a computer where you're actually using it for production purposes. Remove unnecessary services, applications, and protocols. And again, we can look at this from the perspective of a server. And we can say, remove unnecessary services, even on your computer. Your computer can do so much, and they just give you what you require. If you go into your control panel and you configure, add additional features and settings, you can add additional things. Okay, same thing applies to network operating system. They come with a very basic, and it's up to you to configure it to add the services that you need. So really, you don't want all of these services running in the background all at the same time. You need to configure what you need in terms of services, applications, and protocols. If you know very well that you're not going to be using FTP for anything, why are you then enabling port 21 in your firewall? So you're enabling traffic to come in through port 21, but you know you're not going to be using FTP for anything. So that is an exploit. Any services, any applications, any protocols that are not going to be used, remove them or disable them, because some of them are enabled by default. And default settings or default are a very big problem, because most default protocols, default settings, they become a vulnerability for us. Configure user groups and authentication. Okay, if you're looking at it from a network perspective, groups will be more convenient because you define your policies for authentication once. Okay, you're able to put different categories of users into different folders. Maybe if we're talking from a perspective of a college, we have students, we have lecturers, we have assessment and so forth. So you're able to categorize your users using groups, and based on the particular group that the user falls into, then they inherit all of the permissions and different methods of authentication and authorization. Okay, so that's the next step. You configure users, groups, and authentication policies. Then you configure resource controls. What are the resources we're talking about? We're talking about data, program, all of those are resources. Okay, once the users and their associated groups are defined, appropriate permissions can be set on the data and resources to match the specific policy. This may be limited which users can execute some programs, especially those that modify the system state, or it may be limits which users can read or write data in certain directory trees. So once you've defined your user groups, like we did in the previous step, and you defined authorization mechanisms, now you can configure access to resources to say the lecturers group will be assigned these particular data resources or can access or execute these programs on the network. Then we have install additional security controls. Further security possible by installing and configuring additional security tools. Some of the commonly used ones is antivirus software, right? Very common. We all use them on our computers as a layer of protection. Whenever somebody plugs in a flash drive or something with a virus, then it's able to detect it. Host-based firewalls, okay? Firewalls on your, not only at the server level, but also on your computer, because we don't know where you take your computer. You may be fine when you're still on our network, and then you go to a public Wi-Fi, and then you connect, and then there's a breach. So always best to also have at host-based firewalls, activate your firewalls at the host. IDS, or intrusion detection systems, and intrusion prevention software. Okay, so we have intrusion detection and intrusion prevention. Most likely, most modern intrusion detection systems contain both. It's not that it's just only going to detect and leave you hanging. It's going to detect and prevent the malicious software from coming into the system, and you're able to track that somebody tried to do something at some point. And application whitelisting, which means that certain applications would be whitelisted, and only those applications can be installed on the network. So okay, Adobe Reader, Microsoft Office, commonly used applications, anything other than that on this computer would be blacklisted, and then the user cannot attempt to install it. And then the final step would be to test the system security. Okay. Final step in the process is of initially securing the base OS security testing, ensuring previous security configuration steps are correctly implemented. Identify any possible vulnerabilities checklist are included in security hardening guidelines. There are programs specifically designed to review a system to ensure that a system meets basic security requirements. Scan for non-vulnerability. So there's software that you can use to test how vulnerable your computer is, and also you can follow guidelines. There's a checklist and guidelines for hardening. Okay, so once you follow that guideline, it ensures that the products that you produce is a secure operating system or network. Okay, and lastly, security maintenance. It's not something that ends. You're constantly doing it. Okay, because the threats to your network are also increasing, which means you're going to need to constantly review. Okay, so monitoring, logging information, backup monitoring, recovering from security compromises, regularly testing system security, and appropriate software maintenance logging. Okay, so yes, you can look at maintenance as also a feature of security. Patches, updates, all of those stuff are done to improve security. Okay, so that is Unit 9 covering operating system security. Are there any questions regarding the study unit?